Hi, boys and girls. Today we're going to be talking again about force and motion. Today's lesson is really important. It is probably the most important part of our unit in fifth grade science about force and motion. It's about Newton's second law. Now, if you think back to yesterday, we focused on Newton's first law, the law of inertia. The law of inertia, as a reminder, says that an object, wait a minute, an object at rest remains, and you know the rest. How does it remain? It remains at rest. And an object in motion remains in motion, meaning that objects, once they're started or once they're stopped, they like to keep doing what they're doing. They don't want to change what they're doing. And what is the one thing that will make an object stop doing what it's doing? Applying a force until a force is applied. All right, now today's new law goes like this, and it's gonna look really weird and really grown up. It's like this: force equals mass times acceleration, which we already have the definition of force. We know that a force is a what? A push or a pull. So if we want to know the force of something, push or pull, scientists, meaning Sir Isaac Newton, created and figured out this formula equals mass, which is the amount of matter in something, and now acceleration is the one thing you don't know yet. And it's super, super tricky. Like, it'll blow your mind. All right. And especially if you go and tell your parents something, I'm going to give you a parent challenge in a little bit. So here's acceleration. Acceleration. Right. All right. Acceleration is a change. And that's weird to think about, but any change in speed. Now, everyone thinks about acceleration as speeding up, but it's just, in science, a change in speed. That means anytime you change your speed, you're accelerating. Tell your parents that. Tell them that when they put on the brakes, they're accelerating. They won't believe you. You'll have to show them this, and then probably they won't believe me, and you'll have to go Google it to prove it to your parents. Tell them this, word for word. Miss Godfrey says that when you put on the brakes in the car, you're accelerating. And the reason that I'm right is the definition is a change in speed. So when you put on the brakes, are you changing your speed? Yes, you are. All right. So remember, acceleration is literally stopping, starting, because both of those are changes in speed. All right. It can also be getting faster or increasing speed. And it can also be getting slower. Now, that's only one part of it because actually acceleration is a change in velocity. That's the best definition. A change in velocity. Now, from our other videos this week, I told you about velocity. Velocity has two parts: speed plus also direction. Now, here's another thing that might blow your mind, right? When you say that acceleration is a change in velocity, that means acceleration is a change in speed or a change in direction. So here's the deal. Another thing that you can blow your parents' mind with is tell them the next time that you're steering the car that they just accelerated. Again, they're going to think that you are trying to prank them and they won't believe you. So I dare you to do it, but be really nice about it. And here's the thing that you don't do is you don't say, "Hey mom, brake the car." Right? Put the brakes on and then make her like slam it because someone did that once and then the mom kind of got mad at me. So don't do that. But do tell your parents that when you put on the brakes, you are accelerating in science. Make them think that you don't know what you're talking about and then go prove it to them that you're right. Because remember, acceleration is a change in velocity. Any change in speed, any change in direction, going forward, going back, turning left, turning right, getting faster, getting slower, starting or stopping, all is acceleration. And now let's go back to our video.
Look at that ball go! I don't know how you do it.
Just a little luck and a lot of acceleration.
Acceleration? You mean speed?
Nope, acceleration. Speed's just a measure of the distance something travels in a certain amount of time. Acceleration is a change in velocity, both speed and direction.
Oh, I guess that is different.
Definitely. Every time that ball gets knocked by a flipper, takes a sharp turn, or hits a bumper, it either speeds up, slows down, or changes direction.
And all of those are what? Acceleration. Let's watch that part again, because literally everything you see happening in this pinball machine is acceleration.
Bumper. It either speeds up, slows down, or changes direction. That's acceleration.
Wait, it's accelerating even when it slows down?
Even when the speed is decreasing, it's still acceleration. But you can call it deceleration instead of acceleration.
Except that's not technically right. In science, just like I told you, that there was no such thing as cold, right? Technically, there's no such thing as deceleration either. We say that, but it's not true. I mean, it's not scientifically accurate. Just like we have to say cold so we know what the absence of heat is, how it feels to us, we have to have a describing word, which is why people say deceleration. But technically in science, there's no such thing. It's just acceleration. Speeding up, slowing down, getting faster, getting slower, starting, stopping, all are acceleration. And there's literally no such thing as deceleration in science. Now, I disagree with their point in the study jam. Just, that's me though.
Whew, that's a lot of speeding up and slowing down. But what about before all that, when the ball's just sitting still?
Well, when an object is at rest, that's partly inertia at work.
Right? An object at rest stays at until what is applied? A force.
Inertia is the property of matter which states that an object at rest or moving in a straight line stays that way.
So, does that mean inertia slows things down?
Not at all. Inertia is what keeps things steady, whether they're moving or not. It's the constant speed of an object. What you're thinking of is friction.
What's the difference?
A lot. Friction is a force that works against a moving object, like when you ride your skateboard over gravel on the road.
Okay, so let's stop there for a second. Just so you know, and this is just a technicality, but inertia is not a force. Inertia is a property. And I think I mentioned this in a different video. Bill Nye says this at the beginning of every one of his shows. He says, inertia is a property of matter, right? It's a property. And remember, properties are used to describe things. So inertia is a descriptive word more. It's not a force, right? Whereas friction is literally a force that acts on other objects. So the definition up here says a force that works against objects to slow them down. Remember, matter rubs against matter and it slows them down.
When the pinball is slowing down as it rubs against the wood on the flat parts. Those are both examples of friction and how it slows things down.
So, if inertia keeps things steady, what gets them moving in the first place?
To get something moving, we need force. To start, the ball is sitting still, waiting to be rocketed into the game.
Waiting for force.
Yeah! The force is a push or pull that causes an object to move.
Force is a push or a pull, but also I want you to make note of this part right here. All that potential energy stored up when you pull back the lever, I guess, of the ping pong, or sorry, no, not the ping pong, but the pinball, right? Right? When you pull back the pinball, it has potential energy just waiting to and send force into the ball. Potential energy. And what's the energy of motion? Kinetic. So it changes from potential to kinetic. Do you remember when we studied energy transfer? Right? And we talked about how energy can never be created and it can never be destroyed. It can only be transferred from one kind of energy to another. Well, in this example, the potential energy in the pulley thingy of the pinball machine is about to switch into kinetic energy into the ball. And it's not even remotely going to be destroyed, just transferred from the pulley thingy into the ball. That's a little aside note.
Stop or change direction. When I launch it,
Bam!
I apply an unbalanced force, a force stronger than the one keeping it in place. When an unbalanced force is applied to an object, its velocity changes and acceleration occurs.
Nice! It went from sitting still to full speed ahead in a split second.
Right.
Okay, let's stop there just for a second. She mentioned something called unbalanced force, and let's talk about that for just a second on my notebook. All right, there are balanced forces, and a balanced force is when you are applying a balanced force is when you apply the exact same amount of force that's being applied back. So let's just say, for instance, right here we have, I don't know, just a board, right? And then we have me, and I'm pushing on the board with my hands, right? And let's say we have, I don't know, let's just say Mr. Godfrey over here, and Mr. Godfrey is pushing on the board. If we both push, so push with equal force, what will happen to the board? Right? If Mr. Godfrey is pushing just as hard as me and we both push exactly the same amount, what do you think would happen to the board? I bet you've guessed already. I bet you have that the board won't move. And that's what happens when you have balanced forces. Now, in the video, they made it really clear to say that when you push the ping pong ball, not ping pong, sorry, the pinball, with unbalanced forces, then that would be like the same scenario with the board right here. And Mr. Godfrey, he's going to be smiling really big, right? And then there's going to be me over here, and the board's going to be coming at me because he pushed it harder than me, right? Harder push, more force, less force. Board hits me. So unbalanced forces cause movement. All right, you can always stop and add those notes to your paper. And let's go back to the video.
When there's an abrupt change in velocity like that, that's when acceleration is at its peak.
And every time it changes direction, that's acceleration too?
You got it.
Whew! Acceleration's quite a ride, but I think you got me up to speed on what's happening here. Every time it changes direction, that's
All right, I think all you'd have to do is show this video to your parents and they would begin to understand, right? But again, remember that the joke is you're supposed to tell them that when you slow down, you're accelerating, and Miss Godfrey says so, and they're going to think that I'm crazy and insane, and they're not going to believe you. And then you can show them this video, or you can look it up, because look at this. It's so cool. Every time this ping pong ball move, it's accelerating, whether it's getting faster or slower. Remember, changing direction is accelerating too.
acceleration too?
You got it.
Whew! Acceleration's quite a ride, but I think you got me up to speed on what's happening here. Acceleration is a change in velocity, the speed and direction of an object. When a force is applied to an object that changes the object's direction or speed, acceleration occurs. And until that change happens, inertia's always at work, keeping an object at rest or moving in a straight line.
Sounds to me like you're all up to speed when it comes to acceleration, Sam. But now it's time to excel where it counts.
All right, let's stop this video and I'll come at you in a little bit and give you a video of a demonstration to help you see Newton's second law in action. Love you. Mean it.